Okay, today I'm going to uh, talk about a package called mirt. In the previous session, I explained the functionality of the LTM package, which were employed for latent rate modeling uh, in case item response theory models. Uh, uh, the other package that is more functional than the LTM package is the mirt package. Uh, this is you can install the package like before through the install package command. Then you can use the full functionality of this software package. I just recall the mirt package from the library command. This is the full information maximum likelihood estimation of IRT models. It actually uses the IRT models for dichotomous and polytomous response data using unidimensional and even multidimensional latent rate models under the item response theory paradigm. It is also possible to do the exploratory and explanatory or confirmatory models, IRT models, like the factor analysis that you classically use for the exploratory factor analysis and confirmatory factor analysis. You can do the same for item response theory models, because item response theory models are actually a proxial factor analysis model that is a non-linear kind of factor analysis. Okay, so you can do the exploratory and the confirmatory models through the mirt package. It is the main algorithm that this package uses is the EM algorithm, expectation maximization algorithm, and the MHRM algorithm that are some numerical algorithms that we use for this purpose. The main function that you use for the item response theory modeling is also called mirt. The package is called mirt, and the main function, you also call mirt. If you type mirt, you can see the function the similar name to the main package. If you press the F1 button, you can find the help document here for the full information. Actually, it is called full information on item factor analysis. Okay?
So can we watch this later on the screen?
Yes, I'm recording it. The main algorithms, MHRM, stands for Metropolis Hastings Robbins Monroe algorithm. Is the MHRM that actually newer than other methods. It's approved by case 2010. The main function and its arguments are listed in the usage section. You can see the usage section. The arguments or the parts of the syntax for this function. The main ones are the data. Data is a data frame, like before, that you use in LTM package. It may be a response pattern, as you can see here. It may be a response pattern. Not only data frames, raw data can be used, but also data frames, but also response patterns can be used for data analysis. It is actually converted to a data frame. If you provide with the package a response pattern, the package can convert it to a raw data frame and use it for item response theory modeling. Okay?
What's the command? How can we do that? How can we do the conversion? What is the command that we do?
Yes, this is a function.
What is the command exactly?
Wait for it.
Oh.
Wait for it.
Okay.
Don't rush.
Okay, fine.
Okay, I'm going to explain. It's a function that I'm going to explain it. It's a very simple function that you can use. So this is the data, and the model is actually a number. It may be a simple number, for example, 1 for unidimensional model, or 2 for a two-dimensional, or at most 3, maybe appropriate for multidimensional response theory. But I recommend do not use this multidimensional item response theory for more than two-dimensional or three-dimensional, because the parameters will exceed so much, and the model will be inefficient, actually.
So we should not run this for multidimensional variables.
The multidimensional IRT models is useful when you deal with a two-dimensional model. For example, you have a scale that divided to two subscales. Okay, it's appropriate for a two-dimensional model.
More than that, what should we run?
Simple linear factor analysis models. Factor analysis models, confirmatory or exploratory factor analysis models are appropriate. And we have also, if you are going to use the latent trait models, you can also use cognitive diagnostic modeling. That is something different. You can have more traits, even 9, 10, or more than 10 traits for a model.
For example, you have the variable psychological capital. It has some components of resiliency, satisfaction ratio. It's more than 2 components, so it's better to use those linears.
Yes, you can use some linear models, linear factor analysis models. Actually, some models that are appropriate for ordinal data. I just explained a method appropriate for ordinal data in my educational videos. I'm also going to explain it here. That is appropriate for item response, polytomous item response data, like partial credit or ordinal or rating scale models, because the data considerations actually are not actually considered in some factor analysis models in SPSS or in an AMIS, because some models that you use for factor analysis consider that the data is continuous while it's not. Okay, but there are some estimation methods like EWLS that is appropriate for ordinal data, and they actually use some correlation matrix that is derived from the ordinal data, for example, polychoric correlation matrices that are appropriate for ordinal item response data that you use in this kind of questions. Okay. The argument model is also important. You can use just a simple number, or you may want to use a vector, as a vector to provide with the model with different models, item response models for different items. It's also possible in this package, but we usually use the same model for all models. So this is the second important argument for this function. The third most important argument for this function is item type. The item type is actually the basic item response theory model that you use for uh, analysis. Um, there are different and somehow very modern and new models for item response theory compared to the LQM package. Uh, that some of them very new. You didn't read about that a lot, but you can see the models and the abbreviation for these models and provide you with some newer, more not actually modern methodologies for item response theory estimations. So the first and very traditional model is the Rash model. You heard about that? You can use the Rash model for either dichotomous or dichotomous item response data. And in this model, as you can see, the, the constraints applied to the discrimination parameter and the difficulty parameter is estimated through the Rash model. And the 2PL model, 3PL model, even 4PL model is also available in this package. 2-parameter logistic, 3-parameter logistic, even 4-parameter logistic. As I explained before, the 2-parameter logistic, as I explained before, you are including the discrimination parameter to the model. The 3-parameter model also, the guessing parameter is added to the model. And for the 4-parameter model that is not used so much in item response theory model, the upper asymptote actually. The guessing is the lower asymptote, and you may have the upper asymptote for the model. It's the 4-parameter logistic model. You have also the graded response model. The graded response model is actually for ordinal item response data models like the Likert type measurement scales. Okay. You have also the RSM and GRSM. The GRSM is um, more precise than the RSM model. Generalized, actually, it's the generalized version of the graded rating scale model, GRSM. It is also used for the ordinal data, like the graded model. You may want to use the GPCM model or GPSCM IRT model that is about item response data that is partial, that is scored in a partial credit mode. Okay, for example, in essay test, you are partially credited responses. So it is the appropriate model for partial credit scores. And the generalized version of this model called the generalized partial credit model is also uh, it may be used also for ordinal data. It's not just limited for partial credit scores. It may be used for uh, uh, some ordinal data, continuous ordinal data. So you may want to apply different models and select the better fitted model. So our criteria for the best model is the goodness of fit measures and the relative goodness of fit measures, actually, like the log likelihood that I explained before, or some AIC or BIC criteria that used for relative comparison of different item response theory models. You have also this kind of model comparison with structure fusion model. It's something global for um, statistical modeling. You have also the nominal response model, BAC. It's for nominal item responses. Some items may have not some ordinal relationship. The options of the items may have not some ordinal relationship with each other. For example, the religion of the respondent, or some kind of preferences that you ask the respondents to choose, and the options are not necessarily ordinal. These are nominal scales, and these kind of questionnaires may be analyzed through the nominal response theory model, that is the family of item response theory models. You have also some kind of newer item response theory model that you have not heard before, like the ideal model. This is the ideal model. Uh, this is the other model are so old. For example, like the Bach model 1972 or Muraki 1992. Or you can see the ideal model or Giga model is also newer. For example, the ideal model uh, is reference to the Madhu and Oliver's 2006. Okay, it is limited to dichotomous item response data, as you can read here from the information for the model. We have also the Giga model you have not heard before, from Robertson et al. 2000. It is generalized graded unfolding model, as you can read here. It's appropriate for the ordinal data. There are also the multidimensional extension for this kind of model. Some of them are limited for the unidimensional model, but some um, models are appropriate for the multidimensional ones. You can find here from the information of different models. You may want to apply them, and somehow, if you don't know whether it is used for multidimensional case or not, uh, an error term may be appear that it's only limited to, for example, unidimensional. Okay. Um, you have also some very new models compared to others. For example, So and Bolt 2010. These are a 2 PLNRM3 and 3LU or 4, the 2 to 4 parameter nested logistic model, where the 3 PLNRM estimates the lower asymptote only while The 3PL UNRM estimates the upper asymptote only used for this kind of model. This is more newer than the other models. And we have also a spline model and monopoly models that invented by Winsberg et al. And Falk and K 2016. We are not going to apply all of these models. We usually use some variations of Rash models. Rash are so popular, so many tests and questionnaires use the Rash model. As I said, the criteria for choosing a relevant model is to get the fit measures, and the simpler and better fitted model is actually preferable than the other models. Yes, simplicity and deepness of fit measures. If you uh, if you fit some IRT models and you cannot find uh, significant differences in terms of goodness of fit between the models, the simpler model, the Rash, for example, is preferable than the others. So, as you can see, the Rash models are more popular than the other models. There are different, some, some, there are some individual books that are written about the Rash models. That, for example, it's more popular because of its simplicity and the way that it's used. The understanding of this kind of model is better, for example, for parents or other stakeholders, okay, than some other complicated and sophisticated IoT models. These are three important arguments or terms of the syntax that should be uh, mm, used. If you do not choose the item type, the default assumes that item follow a graded or 2PL structure. For example, you have, for example, if you do not specify the item type, the graded response model is automatically applied to the ordinal model, and the two-parameter logistic model is automatically employed for what type of item response data? Dichotomies, okay? The binary dichotomies. So you can change the IRT model to the commands for the item type. Okay? I'm not going to bother you uh, explaining the other arguments. You can find them here. There are so many technical explanation for the arguments. There are also some technical details and theories about the confirmatory and explanatory IRT here. There are some notes that you can find here. And also the IRT models are explained here for dichotomous and polytomous models. We are not going to make our life harder than this. So we skip. You can find the detailed references. And we go for the examples. Okay. The LS87 item response or item response pattern data are available in the MIRT package, ls a t is here. This is, as you can see here, this is an item response pattern. What is an item response pattern? The item response pattern, as you can see here, for example, for a five item scale or chess, not the frequency. It is the pattern for responding to the five item test. For example, how many people res didn't respond to any of the five questions? Hmm? 0, 0, 0, 0, 0. 5 zeros. 12 respondents didn't respond all of the five items, test items. Hmm? And the only
number 2, the item. How many people chose only item 5? 92.
they responded. It's a test. They didn't it showed they just did respond
Item 5.
correctly to the fifth item of the test. Uh, 19 people. It's item response pattern. You know, uh, for a five test item, how many people didn't respond all of the test items? How many got 0? 12 people got 0 score. Hmm? What's the minimum and maximum for this test? 1, 2, 3, 4, 5. What is important that how they got the score 1. Hmm? People who just got the score 1 and did respond to the fifth item. 19.
Score 1 to the item 5.
Yes. A score 1 to the item 4. 1. Like this. And it is also, it actually covers all of the variations. You can actually uh, uh, find the total number of patterns that is possible. How it is possible? We have dichotomous items, 0 and 1. So we have 2 powered by how many items? 2 powered to 5 is equal to what? 32. So we have 32 item response patterns. Okay? It's a pattern. So it's a pattern. Did you get it? Did you get it? So how you expand this table? How you get raw data from this item response pattern? You can use the expand table function. Expand table function. If you have a response pattern, you can expand it to a table, to a raw data table. It's that simple. It's a function. It's a basic function in R that you can convert an item response pattern to a raw data table.
So in our studio, it's not like a space just to copy the Excel and put it in the tables. You just command it and you have
Yes, it's actually that simple. It actually do it for you like this. I name it data. I use the expand table function and I insert the LS87 item response pattern through the parenthesis. If I execute this uh, function, I can find my table like this. Enter. I just pressed enter. I just pressed enter. It's a function. It's a function I use for this item response pattern. I named it data. I execute this function and I converted this item response pattern to a item response table. Now I have a raw data table. I have 1,000 examinees who took a 5-item test and corrected in a true and false manner. Okay? You may want to get the classical test theory statistics as simple like this. It is item stats data. We have Cronbach alpha here. We have the mean for difficulty measures and the total R for the discrimination measures. Okay.
It works so easy. When you first look at a paper and you see these tables and these numbers, it's quite scary. How can I put these tables with these mean scores and blah 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 blah. But with our studio, it's quite simple. What is more difficult in this? What is essential here is to justify these.
To interpret the results.
Yes, interpret the results and justify them. How do you get these data? How is it possible for you to get the correlation effects, the effect sizes? What this, the tables are more easy to use, more easy to put in the paper. I think what remains to be crucial here is to justify the interpretation.
Yes, you are interpreting it through, you're just explaining the measures. This is if you find the Cronbach alpha, you report it in the table.
I don't mean the result part. Report the result part is just based on the scores you've got. You can write the results. What remains to be essential, the crucial part here is to justify these results. For example, the section of discussion.
In discussion.
Yes. To justify the
yes. For example, it's about the problem statement and the main question that you are following. For example, if your main question is which IRT model is better fitted to the, for example, some language tests, you apply the different kind of IRT models, then you justify which model is better fitted to, for example, a closed test. Okay? It's about your topic, your title, article title, your problem statement, and the other parts. But in terms of results, you just explain these numbers and the cut points, and you justify them through numbers. Okay. The first function, the mode 1, we actually we actually apply a unidimensional model that follow the 2PL. we just mentioned, I just mentioned that if you do not specify a hierarchy model, the default model is two-parameter logistic model. So if you call the mirt function, specify the data, the raw data, and the model. One stands for a unidimensional, okay? Like the LTM function I explained before. So the mirt function, I actually converted the LSAT data to a raw data table. I follow the default model, the two-parameter logistic model. I chose a unidimensional model. So I named the model mode, stand for model, mode 1. Okay, I run this model. It's actually an iterative model. In 28 iterations, I got the maximum change near to close to 0. So it is converged. The MHRM model, the algorithm converged to the best estimates. So if I want to know the estimates, I can find the intercepts and the slopes for each item. The intercepts and each slopes for the items in a unidimensional models. I can also use the summary function, it's the COEF, that it stands for coefficients. COEF stands for coefficients, and the coefficients are actually, this is the slope of the item, and this is the intercept of the item. If you run the summary function for the model 1, run, you can find the factor loadings. Okay, F1 is the factor loading for each in terms of the factor analysis that you employed in the linear models, and H2 is the communalities. Okay, the more the factor loading, the better the communalities. Okay. You can plot it easily through the plot function. Come on. Oh, let me run it again. Let me call the trace plot. It's a whole plot for the actually the vertical scale is the total score 0 to 5, and the horizontal axis is the ability. You can see that as the ability increases, the total score also increase in a nonlinear shape form. Okay, this is like this. For the total test, it is also possible you call the trace that the plot is also plot for each item. This is for the each item of the test. You can see that the S-shaped form or the logistic function form is true for almost all of the test items. The horizontal axis is the ability, and the vertical axis is the probability of the answering an item correctly. Okay. So the more shaped the curve, the better fitted the item to the model. For example, item 2 is better fitted. It's more shaped than the others. It is also possible that you ask for, let me, okay, that's enough. That's enough for this session. Your question?